So last quick minute revision on chapter light for class 7. As we have said before, this is not a substitute for textbook, but just meant to be a quick pre-exam revision. First of all, let us see what is light. Light is a form of energy. Light is a form of energy in the same way as sound is a form of energy. Magnetic energy is energy, mechanical energy, chemical energy, electrical energy. In the same way, light is a form of energy. It enables vision. Now, light travels in straight lines. The property of light to always travel in straight line is called the rectilinear propagation of light. So, rectilinear propagation of light means light travels in straight lines. And here we have two experiments to prove that. In the first case, here we have a candle, 3 cardboards with hole in the center, and you see it from this side. There is the position of the eye. You will be able to see the light only if the holes are in one straight line. If the holes are not in one straight line, if you move one of the cardboard, you will not be able to see the light. The second experiment. Here we have a candle or any source of light, and we have a straight tube, and you can see. But if the tube is bent, then the light is blocked and you're not able to see, because light will travel only in straight line. After coming here, it stops. The light is blocked as it cannot bend, proving that light travels in straight lines. Mirror. What's a mirror? Any smooth polished surface can act as a mirror. Any smooth, shiny, polished surface can act as a mirror. It could be a metal plate, for instance, a brass plate or a steel plate. We usually use mirrors made of glass. It is silvered on the back side. So this is a mirror. This is the front of the mirror, and the back side is coated with mercury. This coating with mercury is called silvering. And here we can see that the mirror produces an image. Even water could act as a mirror. For instance, you see the trees are reflected in the water, so this is also acting as a mirror. Next we have reflection. When light rays fall or strike a mirror, the mirror changes the direction of the light. When rays of light strike a mirror, or when rays of light fall on a mirror, the mirror changes the direction of light. This is called reflection. Here we have the light coming from this direction and striking the mirror. It changes the direction and goes in another direction. This change of direction of light by a mirror is called reflection. Now, a mirror can be of 3 types. It can be a plane mirror, a convex mirror, or a concave mirror. A plane mirror where the reflecting surface is flat, like this. It's a flat. A convex mirror where the reflecting surface is bulging outward, like this. You have a bulging reflecting surface. And concave mirror where the reflecting surface is hollowed or curved inward, like this. And this shading, this kind of shading, represents the back side of the mirror. So this is the reflecting surface. Here we have the shading. This is the back of the mirror, and this side is the reflecting surface, which is curved inward, that is a concave mirror. Here we have this shading. This is the back side of the mirror. So this will be the reflecting surface, which is bulging outward. There is a convex mirror. So shading represents the back side of the mirror, and the other side will be reflecting, which can be flat or a straight mirror, which can be curved inwards forming a concave mirror, or it can be bulging outwards forming a convex mirror. Next we have got what is a real image and what is a virtual image. A real image can be cast or obtained on a screen. What is a screen? Just a piece of white cloth. A piece of white cloth or a piece of white board or a piece of white sheet of paper can act as a screen. Even the wall can act as a screen. So real image can be cast or obtained on a screen. It may be a piece of white cloth, even the white painted wall. A virtual image cannot be cast on a screen. For instance, a man is standing here in front of a mirror, and this is the image you see. But if we place a screen here as shown by the dotted line, no image will be cast on this screen. Although you can see the image, but if you place a screen here and a man comes, the man is seeing from here, he will not see any image on the white screen. So this is a virtual image which cannot be cast on a screen. And here we have a real image which is cast on a screen. This is a screen, a piece of white board or a piece of white cloth or a piece of white sheet of paper. The image can be cast on a screen. This is a real image. So a real image can be cast on a screen. A virtual image cannot be cast on a screen. Now, what are the characteristics of an image formed by a plane mirror? This is a man standing in front of a plane mirror. First, we note that the height of the man and the height of the image both are equal. So, image size equal to object size. Next, we note that this distance and this distance are same. See the distance, this one from the mirror, and see this distance. Both are equal. So, image distance is equal to object distance. Image is erect. You're not finding the head downwards. The head is up. Here also the head is up. The feet is down. So, image is erect or upright. And image is laterally inverted, as you can see here. The left side becomes the right side and vice versa. The left side becomes the right side and vice versa. And here also you can see, first we have the blue triangle and then the red triangle. But in the image, it is first red and then blue. Here we have blue followed by red, and here we have red followed by blue. And the reason you can see is that the object distance must be equal to image distance. So blue is at a greater distance. So the image of blue is also at a greater distance. The red is closer to the mirror. So the image of red is also closer to the mirror. So the lateral inversion is actually a property arising from this property, image distance equal to object distance. So the characteristic of a plane mirror image, image size equal to object size. As you can see, both the heights are equal. Image distance equal to object distance. The two distances will be equal. Image is erect or upright and laterally inverted, as you can see here, or you can also see here. Now, next, curved or spherical mirrors. Curved or spherical mirrors may be convex, where we have the reflecting surface bulging outward. As you can see, the reflecting surface bulging outward. Or it can be concave, where it is hollowed or curved inwards, as here it is curved inwards. And here also we have a symbolic diagram. This is the shading representing the back side of the mirror. So the reflecting surface is curved inwards, showing it is a concave mirror. And here, this is the back side of the mirror, and the reflecting surface is bulging outward, showing it is a convex mirror. In order to study convex and concave mirror, you can look onto a steel spoon or bowl held inverted and notice your image at different distances. In case of convex mirror, means if you are holding the spoon upside down, image is always diminished, means image will be always smaller in size. Image is always erect and image is always virtual. So you can see this is the object and this is the image. The image is smaller, but the image is erect. This is the arrow, and here also you have arrow on the top. Image is erect, but image is smaller and virtual. In case of concave mirror, you look into a steel spoon or bowl. not held upside down, but this time you will hold it the right way. Notice your image at different distances. Image may be smaller or larger or of same size. All the sizes are possible. Image may be erect or inverted. Both are possible. Image may be real or virtual. Here, for instance, we have an erect image. You can see the erect image and smaller size. Here, for instance, you can have an image which is inverted. This is the arrow, and here this is the arrow. So you can see an inverted image. So it can be real or inverted. It can be real or virtual. It can be erect or inverted. It can be smaller or larger or of same size. So with concave mirror, everything is possible, but with convex mirror, always smaller image, always erect, and always virtual. What are the uses? It is used by dentist. Here you can see, used by dentist. Here we can see a dentist is using the concave mirror. By ENT specialists. As reflectors in torches, there is a torch, and there is a reflector made of metal, a cup, hollow cup, which makes the ray parallel. So reflectors in torches and in some telescopes. Convex mirror, as rear view mirrors in vehicles. This is a rear view mirror in vehicles we are using because it gives you a wider field of view. As magnifying glasses, you can also use it in buildings for security, the so-called vigilance mirror, and on the outer surface of sunglasses. Now we compare the properties of images in plane mirror, convex mirror, concave mirror. Plane mirror, image size equal to object size. Convex mirror, always image is smaller. Concave, all the sizes are possible. Plane mirror, erect. Convex, always erect. Here both erect and inverted image are possible. In plane mirror, virtual. Here convex mirror, always virtual, but here both real and virtual are possible. Next we have a lens. Now a lens can be concave or convex. We do not have three kinds of lenses. Mirrors, we had three kinds: plane mirror, concave mirror, convex mirror. In lens we have only two kinds of lens, convex and concave. We do not have three kinds of lens. A convex lens is also called a converging lens, and a concave lens is also called a diverging lens. If the middle is thicker, it would be a convex lens, and if the middle is thinner and the edges are thicker, it would be called a concave lens. So convex lens means thicker in the middle, concave lens means thicker at the edges. And here you can see what happens when parallel rays of light pass. A converging lens, all the ray will converge to a point. Diverging lens, all the ray diverge, go farther apart. Now, images formed by convex lens, it can be real or virtual, both are possible. It can be erect or inverted. It can be smaller or larger or of same size. But in case of concave lens, it is always virtual, always erect, and always smaller in size. What are the uses? Convex lens is used as magnifying glasses. It is used in microscopes. Here we have the microscope. Microscope, we are using convex lens. To correct long sight, or technically called hypermetropia, it is also called far-sightedness or long-sightedness. We use them in spectacles. Concave lens in spy or peepholes. These are fitted on the door. These are so-called peepholes or spy holes, where you can see the person standing outside even before you open the door. To correct short sight or myopia, short-sightedness, and in cameras. So these are the uses of convex and concave lenses. So that was Easy Elite English. Hope you have found the video useful. Thank you and goodbye. Join us for more such interesting videos which you can view as a last minute pre-exam revision. Thank you and goodbye.